Hello everyone. I Nilesh Kumar Sen, working as an assistant professor in ABES Engineering College, Ghaziabad. Today's topic is thrashing. Thrashing is a phenomena that occurs in a computer operating system when system spends more time in swapping between uh, physical memory, that is RAM, and the virtual memory, that is disk storage. It is just because of the high demand, memory demand, and low available resources. Mean, considering that we are having a less size of the secondary storage, let's suppose it is about 150 GB and RAM is of 2 GB, and we are having processes that cannot be accommodated into the RAM and not into the secondary storage also. In that case, it becomes necessary for an operating system to constantly swap in and swap out between the processes. And in order to make this will lead for a significant decrease in system performance as CPU is spending the total time in swapping pages. That is actually and not the actual performance on the code. So what does thrashing includes? High CPU utilization. CPU is spending a lot of time swapping pages from memory between physical memory and to the secondary storage or a disk. This will lead to a high CPU utilization even when the system is not performing any significant work. It also increased disk activity. Since system is thrashing an operating system, disk activity increases significantly as system is trying to swap data between physical memory and the virtual memory. High page fault rate, since the virtual memory and the main primary memory is not capable enough to accommodate all the pages that are being recorded for performing a particular task. So frequent swap and swap out is required. So it will increase high page fault rate and slower response time. It is obvious that when system is in thrashing, so response time will slow significantly. If all those symptoms are happening with your system, it is possible that your system is having trouble with thrashing. So you can use a system monitoring tool to check the CPU utilization, page fault rate, and disk activity to confirm whether your system is suffering with the thrashing or not. There are some algorithms that we use during thrashing. So at the time when thrashing starts, then the operating system tries to apply either the global page replacement algorithm or the local page replacement algorithm. Now, one by one, we will look into the matter what is global page and the local page replacement algorithm. So, global page replacement has access to bring any page. Whenever thrashing found, it tries to bring more pages. So, due to this, no process can get enough frames, and as a result, the thrashing will increase more and more. So the global page replacement algorithm is not suitable whenever thrashing happens. And what about local page replacement? So unlike the global page replacement, local page replacement selects pages which only belong to that very process, which is currently being used or executed. So uh, due to local page replacement, there is a chance of reduction in the thrashing, as it is also proved that there are many disadvantages of local page replacement that we earlier discussed. So, local page replacement is simply an alternative for the global page replacement. So, here you can see that as the CPU utilization increases, degree of multi-programming is accordingly or significantly changes when thrashing came into the picture. Causes of thrashing. high degree of multi-programming, number of processes are running on a system. Operating system may not have enough physical memory to accommodate once in a whole. This will lead to thrashing. Constant swapping pages between memory is required. Lack of frames means number of frames are lesser, as frames are the units of memory that are used to store pages of memory. If there are not enough frames available, so operating system will have to swap pages between memory to disk and disk to memory too. Page replacement policies. What kind of algorithm we are actually using while page replacement? Insufficient physical memory is also the cause for thrashing. Inefficient memory management is also one of the reasons, as this will also lead to the fragmentations of physical memory, which again lead to the thrashing. And poorly designed applications. Applications such as excessive memory required or that have poor memory management practices. So such applications will also lead to thrashing. As you can see that higher the page fault rate, it significantly makes changes in increase the number of frames, upper bound, lower bound, and decrease the number of frames too. What are the techniques to prevent thrashing? So increase the amount of physical memory is one of the solutions, and reducing the degree of multi-programming is again a solution, as this will lead for termination or suspending the processes and denying of the new processes from starting. Effective page replacement policy, if we are using, so this will also prevent thrashing, and optimize applications is also an alternative for avoid thrashing. And monitor the system's resource users. That is again a very important factor for prevention of thrashing. Since if we are using monitors, so it will take care about the CPU utilization, memory uses, and disk activity, and will notify you by a message that how many resources are being overutilized and what are the system utilization ratio is, how much memory is required for a particular applications, and various factors it will monitor and will inform you via message. System monitoring tool will also identify bottlenecks in your system if it is having, and system resources uses over time and time. Examples of thrashing. A web server is one of the examples. It may generate threats if it is overloaded with requests and does not have enough memory to handle them all. This can cause the server to become unresponsive. As you can see that, let us consider an example of generating or publishing a results of a students, of a university students. So sooner the result is announced, the BAF server becomes heavier as number of requests are generating, and the uh, system is not having the enough memory to handle all the requests generating from the user. So this will cause a thrashing. Database server, it is again same as web server, but it may have a database. Suppose that there's a database and one is number of users are requesting for to access that same database, and that many queries at the same time, and due to not enough memory available to handle such data, this will lead to slower the database server. Unresponsiveness will be increased, so collectively it will generate a threat. Video editing applications, it depends upon the large video files. So, and a video game, there's a number of video games available in the market that are having numerous scenes, large scenes are required, and does not enough memory to store all of the textures and resources that it requires to smooth going. So this will lead what part of the gaming screens or textures will be loaded into the main memory, and remaining will be kept inside the secondary storage. What what happens when the secondary storage is not enough capable to accommodate all the textures and resources? So this will again resulting a thrashing. These are the references that are used to prepare the stuff